Hello, welcome to Unit 6, Lesson 15, Efficiently Solving Inequalities. The learning objective today is to be able to graph the solutions to inequality on a number line and to solve inequalities by solving a related equation and then checking which values are solutions to the original inequality. So let's go ahead and take a look at our warm-up activity. Now, this says here we have an inequality, negative x is greater than or equal to negative 4. Remember in the past couple days we've talked about how negative x, another way of saying that, is the opposite of x. So you are basically finding numbers that when you take the opposite of them, they are greater than or equal to negative 4. So go ahead, answer questions 1, 2, and 3. We'll pause the video and then come back in a short while. All right, let's take a look at question 1. So number 1 says, predict what you think the solutions on the number line will look like. So if we want numbers that are the opposite of x, when you take the opposite of them, they're greater than negative 4. That means they have to start out as positive to make them negative. So right off the bat, I know I'm going to have a positive 4 because opposite of positive 4 is a negative 4. Then I need to think of, okay, am I going to be looking at numbers bigger than 4 or less than 4? So the other one to think about, a number less than 4, is 0. If I plug 0 in, right, 0 is just always 0. It's never not negative nor positive. 0 continues to be greater than negative 4. So I know I'm going to be looking at numbers that are positive 4 and smaller. So positive 4 and smaller. So the values that would fit that, 3 would work, negative 3 would work, 4 would work, negative 4 would work, 4.001 will not work, but negative 4.001 will work. Now let's go ahead and graph these on a number line. So basically I want all numbers less than or equal to 4. So I'm going to put 4 in the middle and build my number line around it. I'm going to have a closed circle because I want to include 4 in the solution, and my arrow is going to point to the left. Now keep in mind that these are different than the solutions for numbers greater than 4, right? Those numbers, the graph would be pointing to the right. And yesterday, our last couple of problems, we looked at how the inequality symbol that we started with was different than what we ended up with, right? So here we started with a greater than inequality symbol, but ended up with a less than. So that is important that you're really thinking about the solution types. All right, let's take a look at the second activity. So here we're going to be using tables to help us investigate solutions to inequalities. So we have a table. On top we have the values of x, and then on bottom we have the values of x minus 3. So basically what you're doing is you are plugging in the numbers to x and seeing what it equals. So for number 1, we have negative 4, and if we do negative 4, if we do negative 4 minus 3 or plus negative 3, that's going to equal negative 7, right? Negative 2 plus negative 3 is going to equal negative 5. So go ahead, pause the video, continue filling out the rest of the table, and restart the video. All right, let's fill out the rest of the table together. So here I'm going to do negative 3 plus negative 3, which is negative 6. Here I'm going to do negative 1 plus negative 3, which is negative 4. Then we have 0 plus negative 3, which is negative 3. 1 plus negative 3 is negative 2. And finally, 3 plus -3 is 0. So hopefully you saw the pattern too, right? Each number went down by 1. The next question says, for which values of x is it true that x minus 3 is equal to -2? And C says, for which values of x is it true that it's greater than -2? And then finally, graph the inequality on the number line. So go ahead, pause the video, answer those 3 questions, and restart it up. Alrighty, so let's take a look. Where do we see where x minus 3 is equal to -2? And that shows up right here. So that tells me when x is equal to 1, x minus 3 equals -2. And then we're also looking for where the values are greater than -2. So I have to decide which side of the -2 shows me numbers that are greater. So if I look at my table, I can see that my numbers are greater over here. So as x gets bigger, so do the x minus 3. So I know for x equals 2, 3, and 4. So now that I know that, I can write an inequality that represents the solution. It's going to be x is greater than 1. So to graph that, I'm going to put a 1 in the middle of my table or number line and build my number line around it. This time I'm going to have an open circle because I do not want to include 1 as a solution. And then I'm going to draw my arrow to the right. Question 2 gives you a new inequality. And I know that the table did not provide you with the filled out parts. So I'm going to show you what those filled out parts should be. So here we should have an x. And then -4, -3, -2, -1, 0, 1, 2, 3, 4. And then over here, we should have -2x. So for this question, you are again going to predict which values will make the inequality 2x is less than 6 true. Then you are going to complete the table. And then you are going to graph the inequality and stop there. So go ahead, pause the video, and complete those 3 questions in the next 2 minutes. All right, so what values of x will make this true? So again, I know I need to think about 2x. What do I need to multiply by 2? So I end up with 6. Well, I know 2 times 3 is 6. So that will tell me if I'm exactly at 6. So if I think about it, if I multiply by numbers less than 3, so for example 2, that will provide me numbers less than 6. So I know I'm going to be looking at numbers that are less than 3. So now I'm going to fill out the table to make sure that that makes sense. So here I'm doing 2 times 4, -4, which is -8. 2 times -3, which is -6. 2 times -2, which is -4. 2 times -1, which is -2. 2 times 0, which is 0. 2 times 1, which is 2. 2 times 2, which is 4. 2 times 3, which is 6. And then 2 times 4, which is 8. So if I look here, I can see all of the numbers that are less than 3 give me an answer that is less than 6. So I know that my prediction was correct. So I know that I need the numbers less than 3. So to graph that, I start by putting my 3 in the middle and then build my number line around that. I'm going to put my circle on the 3. It's not going to include the 3, so it does need to be open. And then I'm going to draw my arrow to the left. All right, let's look at question 3. Question 3, similar, but now we're looking at a negative 2x. So again, I noticed the table is not filled in for you, so let's go ahead and fill that table in. So here we have x, negative 4, negative 3, 2, negative 1, 0, 1, 2, 3, and 4. This time we're using negative 2x. So let's reason this one out together. So we want the negative 2x. So we're thinking of this as when we multiply negative 2 by a number, what will give us a positive 6? Well, a negative times a negative is a positive, so I know I need to do negative 2 times negative 3. Now I need to decide, though, in what direction do I have to go. So I know I'm starting at negative 3, but I need to ask myself, will the numbers bigger than negative 3 keep it as a true statement, or less than negative 3 keep it as a true statement? So we want numbers that are smaller than 6. So if I think of starting with, let's say, negative 2 times negative 2, that will give me a positive 4. So I know 4 is smaller than 6. So I know I need numbers that are actually greater than 3. Negative 3, sorry. Greater than negative 3. So go ahead, pause the video, and check to make sure that we're correct with that, and also graph it on a number line. All right, let's take a look at that. So first we do negative 2 times negative 4, and we get positive 8. Negative 2 times negative 3 is positive 6. Negative 2 times negative 2 is positive 4. Negative 2 times negative 1 is positive 2. Negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6. And negative 2 times 4 is negative 8. So I see that as I move to the right of my table, that my values do stay smaller than 6. So I know that I made an accurate prediction. So let's go ahead and make a number line. So I'm going to start with my negative 3 in the middle, build my number line around that negative 3. So I need an open circle again because negative 3 is not part of the solution set. And I'm going to draw my arrow to the right. So in this activity, we took a look at 3 different situations, and we saw that the direction in which our solutions run do not always match up with the inequality symbol. The first 2 was fine. The direction the inequality symbol started with is the direction that we ended with. But the last one, it did not go that way, right? We started with a less than symbol, but we ended up choosing numbers that are bigger than, greater than the solution. So it's really important that when you are solving for your inequalities, that you're checking your solutions to make sure it makes sense. My recommendation is either fill out a table like we did, or you can choose a number either above or below the boundary point and plug it in to see if it's true or not. And then you know which way to flip the inequality. All right, let's take a look at the next activity. So in this activity, we're continuing with this idea of solving inequalities. First, we're starting with negative 4x plus 5 is greater than or equal to 25. You're going to solve it like an equation, and then it asks you a couple of questions to determine which way you're going to be drawing your arrow for the solution set. So I want you to go ahead and do number 1 on your own, so pause the video. We're going to skip number 2. So we're skipping number 2. And then I want you to continue on to number 3 and 4. So you're doing questions 1, 3, and 4 for this activity. So go ahead, pause the video, and work on that. All right, let's take a look at the first inequality. So it says to solve it as an equation first. So let's go through that process. First, I'm going to subtract 5 from both sides. That gives me negative 4x equals 20. Then divide both sides by negative 4, and I get 1x is equal to negative 5. So I know that when the x is negative 5, negative 4x plus 5 is equal to exactly 25. But I need it to be greater than or equal to 25. So we need to decide if I want solutions bigger than negative 5 or smaller than negative 5. So what I'm going to do is plug in x for 0. Now this is a number bigger than 5. So when I plug in x for 0, I have 4. Negative 4 times 0 plus 5. Well, negative 4 times 0 is 0, and 0 plus 5 is 5. So we're asking ourselves, is 5 greater than or equal to 25? That's the question we're asking ourselves. And it's not, right? It's smaller, so that's a no. What about when x is 7? So now we're still looking at numbers that are bigger, right? So let's try 7. So this time I'm going to do negative 4 times 7 plus 5. Negative 4 times 7 is negative 28, and negative 28 plus 5 is negative 23. So again, we're asking ourselves, is negative 23 greater than or equal to 25? That's the question. And again, no, it's smaller. What about when x is negative 7? So now we're looking at numbers smaller than the negative 5. So I'll plug in negative 7. So negative 4 times negative 7 plus 5. Well, negative 4 times negative 7 is positive 28. 28 plus 5 is 33. So again, is 33 greater than or equal to 25? And in this case, yes. So this tells us that we want numbers smaller than or equal to negative 5, because that will give us true solutions that end up being true. Let's go ahead and graph that. So I start with negative 5 in the middle, build my number line around it. This time I'm going to use a closed circle because negative 5 is a solution, and I want the numbers going to the left. Let's go on to number 3. Okay, so this time it wants you to solve, and it doesn't break it down for you, so there's a little scaffolding happening here. So let's take a look. 3 times x plus 4 is greater than 17.4. I'm going to erase that greater than sign, and I'm actually going to make it an equal sign. We're going to start with that equal sign. So let's start by solving this. Now, remember, whenever we have grouping symbols, the first step is always going to be multiply or divide. I'm just going to stick with division, so I'm going to divide both sides by 3. So 17.4 divided by 3 is 5.8. Oops. So now I have 1x plus 4 is equal to 5.8. And then I'm going to subtract 4 from both sides. So I have 1x is equal to 1.8. So this is telling us that when x is 1.8, 3 times x plus 4 is going to be exactly 17.4. But again, we don't want it to be exactly 17.4. So we need to decide, do we want numbers bigger than 1.8 or smaller than 1.8? So let's do a solution test. I always like to use 0 because 0 is a good way to check. So 0, so I'm going to start with 0, which is smaller than 1.8. And I'm going to plug that in. So I have 3 times 0 plus 4. 0 plus 4 is 4. 3 times 4 is 12. And then I ask myself, is 12 greater than 17.4? And no, it's smaller, so that's not going to work. So I chose a number smaller than 1.8. Let's choose a number bigger than 1.8. Let's do 2. So 2 is bigger. So plug in 2. 2 plus 4 is 6. 6 times 3 is 18. Is 18 greater than 17.4? And in this case, yes, it is. So I know my winner is the bigger number. So I need this numbers, my solutions are going to be greater than 1.8. Now, when I graph this on my number line, you have a choice. You can do it by whole numbers or you can do it by decimals. I'm going to go by decimals just because. So I'm going to do 1.8, 1.9, 2, 2.1, 2.2, 2.3. From here, I'm going to go backwards. So 1.7, 1.6, 1.5, 1.4, and 1.3. Again, open circle because 1.8 is not part of the solution. And I go to the right because that's where my bigger numbers are. All right, let's take a look at the last one. So for this last one, because I'm dealing with a fraction here, it actually makes sense to distribute first rather than divide first. You kind of have to look at your situation and decide. I know if I multiply -3 by 4/3, I'm going to end up with a whole number. So first I'm going to rewrite this as addition. And I'm going to start by distributing. So I'm going to do 3 times each of those. So that gives me 3x plus 4 is less than or equal to 6. Now, if you divided by 3 first, and actually I don't even want the inequality symbol. Let's change that to 2 equal signs. So again, if you want to divide by -3 first, that's fine as well. But distributing just gets rid of the fraction, which makes it a little less messy. So from here, I'm going to subtract 4 from both sides. So I end up with -3x is equal to 2. And then divide both sides by -3. So now I have 1x is equal to -2/3. Notice I'm not writing this as a repeating decimal. I'm leaving it as a fraction. So I know that when x is -2/3, this whole thing right here is going to be equal to 6, but I need numbers that give me less than 6. So I have to do a solution test to determine if I want numbers bigger than the -2/3 or smaller than the -2/3. So I'm going to start with 0. I always like 0, and in this case 0 is bigger than 2/3. So when I plug 0 in, I have 0 minus 4/3, which is just -4/3, and then -3 times -4/3 is a +4. +4 is indeed less than or equal to 6, so that is a true statement. But let's just do another solution test just in case. So now we choose a number smaller than -2/3, and you could use -1, so that one's smaller. So when I plug in -1 minus 4/3, remember -1 is just -3/3. So I know that's going to give me -7/3, which is going to then, when I multiply that by -3, will give me a +7. So I asked myself, is +7 less than or equal to 6? And no, it's not. So I know my winner is my bigger situation. So I'm going to write an inequality that says x, switch to pen, x is greater or equal to -2/3. All right, so let's go ahead and graph this now. So I'm going to put -2/3 in the middle and then build my number line around that. So to the right I get bigger, so that's -1/3, 0, 1/3, 2/3, 3/3 is just 1. Going to the left, -3/3 is just -1. Then I have -1 and 1/3, -1 and 2/3, and then -2 and -2 and 1/3. So this time I'm using a closed circle because -2/3 is part of the solution, and I want my arrow to go to the right. So again, we had some inequalities where we did not end up graphing in the same direction that we started with. And looking closer at those situations, so the first situation we had, or one situation we had, was here, right? We ended up switching. And the other one was up here. We again switched. And if we ask ourselves, what did both of those situations have in common? You may have noticed that they were both had some kind of division by a negative number. We divided by a negative number here, and then we also divided by a negative number here. So this tells us that whenever we're dividing by a negative number, you need to flip the inequality symbol. Now, if you can't remember that strategy, then at least do solution tests every time you solve an inequality, like we were doing with these 3 previous problems. We chose a number bigger than the solution to the equation and smaller, and we saw which one ended up being the accurate statement. So that's it for today's lesson. Go ahead and submit these notes for participation points. Thanks for watching.